Okay guys, now solving these questions. Substitution in definite integrals. When a substitution is made in a definite integral, the limits of integration should also be changed. Now you can see here limits are 2 and 1. Now when we are going to substitute in place of the given question, we have to change these limits also. Now in what way we have to substitute? We are supposing that let u equals x square plus 2x plus 2, right? Now taking the derivative du upon dx, this gives us 2x plus 2, and taking finding du. How can we find du? That is, you can take 2 as a common from here, x plus 1 dx, right? Now this is the derivative. Now how can we change these limits, upper limit and lower limit? We have to put this 2 and 1 individually, one by one, in this given supposition value. That will give the new limits for the question. So u, in place of x here, I'm going to substitute 1, the lower limit. So what happens? 1 square plus 2 into 1 plus 2. That gives 2 plus 2, 4 plus 1, 5. So in place of 1, after substitution, we have to write 1 here. We have to write this 5 here, right? So the second upper limit, that is 2. Do write 2 here, plus 2 into 2 plus 2 is 4 plus 4 plus 2, that is 10. Now the new form after substitution, the question will be, this question will be now in a different form, like the upper limit, that is 10. Okay. Now in place of this 2, I have to write 10, and in this place of 1, I am going to write 5, right? So after substitution, you can see here our du equals 2 into x plus 1 dx. Here we have x plus 1 dx. So in place of this, I'm going to write this part, okay, this part. So let's take a bit change here. Tu upon 2, that is, this gives x plus 1 dx. So in place of this part, I'm going to write u, and in place of this x plus 1 and dx, this x plus 1 dx, I'm going to write du upon 2. Okay, now take this 1 upon 2 outside, and now solving 1 upon 2 u power 1 upon 3 10 5 du. Now we can simply find the integral by taking 1 upon 3 plus 1 divided by 1 upon 3 plus 1, 10 and 5, putting the upper limit and lower limit. So that gives us u power 3 plus 1 4, 4 plus 1 5 upon 3, 4 upon 3, the 4 upon 3, that gives 10 5. Okay, now that gives, here move this 4 upon 3 up here, that gives you 3 upon 8 u power 4 upon 3. You can put 10 and 5 individually now. 3 upon 8 that will give you 10's power 4 upon 3 minus 5 power 4 upon 3. So after solving this whole part, or this is your answer, or you can simplify further, which will be the same. So keep it as an answer. Okay guys, I'm going to solve this question by using the same procedure. First, I have supposed 3t minus 1, that is equal, let z equals 3t minus 1. So taking the derivative of this z with respect to t, that gives me the value 3. Okay, now converting, taking some value for dt over here, the dt will be equal to dz upon 3. dt will, I'm going to cross multiply this dt over here and 3 down into the denominator of dz. So this dt equals dz upon 3, right? So after taking this supposition, I'm going to change the limits also, right? So that is z equals 3. First change the lower limit, that is 0 minus 1, that is minus 1, and the upper limit, that is 3 into 3 minus 1, that is 9 minus 1 is equal to 8. Now putting the values, that will give me, the upper limit is 8 now, the lower limit is minus 1, and in place of 3t minus 1 I'm going to put z. Here I have 3 and here square. In place of dt I'm going to write dz upon 3. Take out this 1 upon 3 outside here, 8 minus 1. Now remove this cube root and write it as in form of fraction. That will give me 2 upon 3 here dz. Taking the integral now, that will provide 2 upon 3 plus 1, 2 upon 3 plus 1, upper limit is 8, lower limit is minus 1. So further simplify 1 upon 3, this z power, that will give me 5 upon 3, 5 upon 3, 8 minus 1, right? This is 8 and this is minus 1. Now take this fraction just next to 1 upon 3, that will give me a new form, that is 1 upon 3 and 3 upon 5, that will be 5 upon 3, 8 minus 1. So I'm going to cancel out this 3 and 3 here. I'm left with 1 upon 5. In place of z, I'm going to write 8, 5 upon 3 minus into minus 1, 5 upon 3, bracket closed, right? 1 upon 5, I'm going to write in place of 8, I'm going to write 2 power 3, 5 upon 3 minus, in place of minus 1, taking fifth power of minus 1, and 1 upon 3 is outside, that will cancel out this 3 and 3, 1 upon 5, that will provide me now 2 power 5, and I am left with minus into, since the power is odd, the 1 remains as it is, and I have power 1 upon 3, and again you can see here 2 power, fifth power of 2 is 32 minus, and that will give me again minus 1. So 1 upon 5 32 plus 1, 1 upon 5 into 33, that will be 33 upon 5, and this is my final answer in numeric form. Okay, now solving this question, let take t equals 2 minus x dt upon dx, that will give you minus 1, and to get dx I'm going to take this minus 1 on the other side, that will give me dt upon minus 1, and that is dx. So we can write minus dt equals dx. Now changing the limits, t equals the lower limit, that is 2 minus x, take the lower limit, that is minus 2, that will give me plus 4. Now the upper limit, that is 2 minus into 1, 2 minus 1 is 1. Now putting all these values, by substituting the values in the given question, that is the lower limit is 4 and the upper limit is 1, and in place of this 2 minus x I am going to write t, and in place of dx I am going to write minus dt, and that will give me minus, take this minus 1 outside this integral sign and convert this root value in form of 1 upon 2 and dt. Now finding the integral, that gives me 1 upon 2 plus 1, 1 upon 2 plus 1, 1, 4. Now solving for this, minus t power 3 upon 2, that will be 1 and 4, and in place of this, putting the values of the limits in the question, that will give me, take this 2 upon 3 up into the numerator, that will give me minus 2 upon 3 and t power 3 upon 2, 1 and 4. Now insert the limits one by one. First the upper limit, that will give me 1 power 3 upon 2 minus 4 3 upon 2, bracket closed, minus 2 upon 3. Now solving, take any power of 1 is always, that gives you 1 minus 2 square, multiply by 3 upon 2, 2 cancel, and that will give you minus 2 upon 3, 1 minus 2 power 3, that will be minus 2 upon 3, 1 minus 8, minus 2 upon 3, give you minus 7, and that gives you 14 upon 3. That is our final answer. Okay, using the same procedure, let u equals x minus 1, take the derivative du upon dx, that is 1 du equals dx, right? Now change the limits, u equals x minus 1, the lower limit, in place of x just put the value minus 3 minus 1, that gives you minus 4, and the upper limit, that is x minus 1, put the value of minus 1 in place of x, and that will give you minus 2. Now putting the values, the new form of the question will be that is minus 2 is the upper limit, minus 4 is the lower limit. So in place of x minus 1, I'm going to write, that is u power 3, and in place of dx I'm going to write du, right? the whole form of the question is changed now. Move this u power 3 into the numerator. We can write it as u power minus 3 du, right? Now take the derivative minus 3 plus 1 divided by minus 3 plus 1 minus 2 minus 4, right? U power minus 2 upon minus 2, that is minus 2 upon minus 4, and now take this minus 2 outside here, minus 1 upon 2 u power minus 2, or we can put this we can take this u into the numerator again by saying that minus 1 upon 2 1 upon u square minus 2 minus 4. Now putting the values 1 upon upper limit is minus 2 square minus 1 upon minus 4 square minus 1 upon 2, that is 1 upon 4 minus 1 upon 16, that will be 1 upon 2, that gives me 16 here. 4 minus 1, simple, find the LCM, that will be 3 upon 16 minus 3 upon 32. This is our final answer.